Hello, Leiden geometry students. In this assignment, we are going to talk about scale factor. Scale factor is where when you have two similar shapes, it's how many times larger or how many times smaller one of them is compared to the other. For example, here we have a triangle. The angles are marked. They're all different. We don't know anything about those angles. But we do know the measurements of the sides. Now we're going to take this triangle and we're going to create we're going to perform a dilation to create a triangle that's half the size. So it'll have a scale factor of 1/2. Now first I've created an exact copy, then I'm going to grab it and we're going to change it. We're going to shrink it down to 50% of its original size. Whoops, that's 150, 50% of the original size. And now I have a much smaller triangle. And since we said the scale, each of the side lengths is now 1/2 of the original one. They're 3, 4, and 6. Now, that's what happened to the sides. But before we do anything else with scale factor, when we talk about similarity, the sides change by the scale factor, but the angles do not. If you notice, we have the same blue angle on both the triangles. If we look at them, the angle is still the exact same size. Those blue angles overlap perfectly. The angle did not go down to half the size. The sides did. The blue angle is still the same. If we move this over here, the green angle still has the same measure. If we move it over here, the red angle still has the exact same measure. So when we talk about similar triangles, the sides change lengths, but the angles do not. So now let's talk about those scale factors. Here we see the SSE Tuatara. It's the world's fastest production car. It set a record in October of 2020 for 316 miles an hour. That is a very fast car. And then this one down here, it's a scale model of it, but it's made of Legos. Now, in previous problems about similarity, we would give you these measurements, and we'd say, hey, find out what x is. And what you would do is you would set up a proportion, cross multiply to solve, and this side would turn out to be 180. It was x a minute ago. But that's not what we're going to talk about now. What we're going to talk about is how many times larger the big car is or how many times smaller the small car is. So it's that how many times larger or how many times smaller that's called the scale factor. In other words, if these two shapes are similar, I should be able to figure out what I would multiply 15 by to get 180. It would be the same thing we'd multiply 7 by to get 84. That number is going to be called the scale factor. To find the scale factor here, what we do is we take a measurement in one of the objects and divide it by the corresponding measurement in the other one. In other words, we take 180 and divide it by its corresponding measure, 15, and we'd get 12. If these shapes are truly similar, we should get the same thing with the 84 and the 7. 84 divided by 7, oh, good, that also turns out to be 12. So our scale factor is 12, but scale factor could go either way. Instead of doing 180 divided by 15, we could do 15 divided by 180. So when we say our scale factor is 12, it actually could be either 12, 12 over 1, or 1 over 12, depending on which way we go. Every pair of similar objects have two scale factors, and we will want to be able to use both of them. For example, if we know a measurement in the small object, here this 15 inches down in the bottom left, and we want to know the corresponding in the big measurement in the big one, all we have to do is multiply by one of the scale factors. Now, we know that the measurement in the big car should be larger than the measurement in the small car. So we're going to just take that 15 times the scale factor. But as I just said, there's two scale factors. Well, you kind of have to know ahead of time whether you want to get larger or smaller. In this case, we know we want a bigger measurement. If we want a bigger measurement, we multiply by the scale factor with the bigger number on top. So 15 times 12 over 1 would give us the 180. If we were going the other way, here I know the 84 is a measurement in the large car. If I want the corresponding measurement in the small car, I know I want to get smaller. So we'd multiply by the scale factor that has the smaller number on top. So 84 times 112 would give us the measurement in the small car. See, when it comes to scale factor, there's basically two types of questions. One is, here are two objects. What is the scale factor? In other words, how many times larger or how many times smaller are the two objects? Or two, here's the scale factor. Use it to find one of the missing measurements. Now, for both those types of problems, the first thing you always have to do is identify your corresponding parts. For example, we want to figure out which parts in the first triangle match up with which parts in the second triangle. This is kind of easy in this problem because it hasn't been rotated or reflected. But like the 24 in the big triangle matches up with the 8 in the small triangle. We could do 24 divided by 8 or 8 divided by 24. And what we want to do is reduce those fractions. If you reduce those fractions, you're going to get 3 over 1 or 1 over 3. These two numbers are our scale factor. Now, if the shapes are similar, that should work with any pair of sides. We could compare the 12 and the 4. If we do 12 over 4 or 4 over 12, that should reduce to the same scale factor, 3 over 1 or 1 over 3, and it does. We should get the same thing again if we use the 18 and the 6. 18 over 6 or 6 over 18, we again get 3 over 1 and 1 over 3 as our two scale factors. So here's a sample problem where we have two triangles and I'm telling you they're similar. What I want you to do is find the scale factor. There's two possible answers. They should be directly connected to each other. So find the scale factor between these two triangles. Well, first step, match up the sides, pair up which ones go together. You could use the 40 and the 24, or you could use the 35 and the 21, or you could use the 20 and the 12. Now, when we compare these things, notice I put all the measurements from the big triangle on top, little one on bottom. You could do it the other way around. You could put all the little ones on top and the big ones on bottom. That's fine as well. But what should happen is these should all reduce to the same thing. What does this end up being? Well, in all three cases, these fractions reduce to 5 over 3. Yes, you do have to be able to reduce fractions to do this. Now, here's an example of a harder find the scale factor problem. Directions are still the same. We still do this problem the same, but if you look at the two triangles, they've been rotated around. So identifying which sides go together can be tricky. In this case, we know all three pairs of sides. So there's actually a really simple shortcut here. You make sure you compare the largest side in one triangle to the largest side in the other triangle, the smallest side to the smallest side, or the medium to the medium. So when you pair up your sides in this case, we want to compare the 18, let's say the largest side is 30. What's the largest side in the small triangle? The 20. So you could compare those two. The smallest to the smallest, well, the small side over here is 15. What's the small side in the other triangle? It's the 10. And the medium side, 18, should pair up with 12. So you can compare any of these three pairs of sides, and all of them should reduce to the same fraction. And that fraction is our scale factor. And in this case, our scale factor would be 2 over 3, or if you did it the other way around, 3 over 2. Now, let's just say you grow up to be rich, really rich. Like you are a professional basketball player rich, and it comes time that you have to build your mansion. When you do this, you don't just start slapping stuff up. You hire an architect to come up with a cool design for your mansion. And usually, a lot of times when architects do this, they build a little scale model first so you can look at it and decide if you like it. So here is the scale model of your future mansion. And what we want to do is, number one, if you ever see one of these things, the first thing they'll tell you is what the scale factor is. And the ratio is 3 to 100. That means a measurement that's 3 inches in the model is actually 100 inches in real life. So we're going to use that scale factor to find a few measurements. So first off, if the model, the toy home, is 18 inches tall, how tall would the real home be? Well, you take the measurement in the model and multiply it by the scale factor. Before you do it, you should know ahead of time, is your answer going to be more than 18 inches or less than 18 inches? Because if it goes the wrong way, you may have to flip your scale factor. And in this case, we just take the 18 inches times 3 over 100. But wait, that gives us 0.54 inches. That's not right. You can't fit in a house that's 0.54 inches. That means we have the scale factor upside down. So we're going to flip it and make it 100 over 3. 18 inches times 100 over 3 gives us a 600-inch tall house. That may not make too much sense, but 50 feet would if you divide that by 12. So it's really common that that people have their scale factor upside down. If that's the case, you should know before you start the problem whether you should get a larger number for an answer or a smaller number. It'll save you a lot of trouble. Same picture, same scale factor. Let's say we have a measurement in real life. We want a 60-foot or 720-inch swimming pool. We're going to use the inches. It'll make our life a bit easier. How big should that swimming pool be in our model? Well, if we want to figure that out, we're just going to take our measurement, 720 inches, and multiply by the scale factor. But you should know ahead of time, since this is the measurement in the real house, should our answer for the model be larger or smaller? Yeah, the model should be smaller. So find the measurement for the swimming pool in the model. Well, we just take that 720 inches and we multiply it by 3 over 100. And in this case, we get 21.6 inches. Perfect. That seems like a little toy swimming pool. Now, mansions might be a little unrealistic for a lot of us, so let's talk about something a little bit more realistic, the Avengers movies. And one of those there Avenger movies, Ant-Man, who's normally 6 feet tall, grows to giant Ant-Man who's 216 feet tall. What was the scale factor that would convert little Ant-Man to big Ant-Man? Well, all we got to do is take the measurement from the before or after. Let's take giant Ant-Man, 216 feet, and divide it by the other sized Ant-Man, 6 feet. And when we reduce that, we should get our scale factor. So 216 divided by 6, and we should get 36. So the scale factor from little Ant-Man to big Ant-Man was 36. He grew 36 times larger than he was. All right, another Ant-Man problem. Let's say Ant-Man, now this time we're going to get smaller. He's normally 72 inches tall, and he shrinks with a scale factor of 3 to 144. That 3 to 144 is the way it's written there is a ratio, but we can use that as a fraction that can be 3 over 144. Now we're going to take a 72-inch tall person and multiply by our scale factor to figure out how tall tiny Ant-Man is. So to do that, we take 72 times 3 over, times 3 over 144. Or if you don't have a fraction button on your calculator, 72 times 3 divided by 144. And we should get 1.5 inches tall. That's how tall a little tiny Ant-Man is.